A rational number is a number that can be written as a ratio. Obviously, you see ratio in rational numbers. Now, it's important to remember that ratio, when we're talking about ratios, we're talking about fractions, essentially. That's an easy way to think of it as a fraction. So, for example, you might have 4/5. There's a rational number. Now, if you want to write this number as a decimal, you can just take 4 and divide 5 into it. Now, does 5 go into 4? No, it does not. Does 5 go into 4D? 8 times, okay? 40, subtract, no remainder. Remember, you put decimal here, bring it up here. 4/5 is equal to 0.8, okay? That's a rational number, taking it from a fraction to a terminating decimal. It's terminating, it's not repeating. There's no 8, 1, 2, 1, 2, 1, 2, 1, 2. So for an example where you might see a repeating, let's go with 4 over 33. Okay, we're going to repeat the same process for trying to find how to write this number as a decimal. We're going to take 4 and divide it by 33. Does that go into 4? No, of course not. Does it go into 4D? Once. Remember, bring your decimal. 40 minus 30 is going to be 7. Drop that 0 down, 70. Does 33 go into 70? That would be 2 times. You're going to get 66. Subtract that, you're going to get 4. Now if you notice, we started with 4. We have 4 again. Bring this one down. We're going to have 40. Again, we're going to have a 1. 33. Subtract 7. Bring this 0 down. 70. How many times does 33 go into 70? 2. So what we have is a repeating decimal. 1, 2, 1, 2. Which you would write 0.12 with a bar over the top to show that both these numbers, make sure your bar is over top of 1 and 2 because they are both repeating. So for a rational number, any two numbers, and it's important to remember your denominator is not 0, right? You can't divide by 0. There should not be 0 in your denominator. So we have a terminating decimal, we have a repeating decimal. Now what if you wanted to convert, say, a repeating decimal back into a fraction? Okay, so let's pick one that's a little bit interesting. How about we'll say 4 5/6. Now, if we want to convert this into a decimal, first thing we want to do is we're going to take that whole number out. That whole number is this. We're going to have a 4 in our decimal. We know that much. So now we want to look at the 5/6 part. Let's take a 5, divide it by 6. Doesn't go in. How about into 50? Okay, this it does. How many times? 8. We get a 48. We have a 2 come down. We have a 3. Oh, we have a 0, which 6 goes into 23 times. 18. This one we see is going to be repeating again. So we're going to have decimals right up front because 6 didn't go into 5 the first time. We have to add this 0.83 onto this 4. We had that whole number of 4. We should have a whole number of 4 here. And we'll have 4.83. In this case, the bar is only over the 3 because it's just going to be the 3 repeating. We had 20 minus 18 is 2. If we brought another one down, we would just keep getting 3's. So we have 4.83. That one's going to keep repeating. So now let's do an example where we take a decimal and convert that into a fraction. We're going to take 2.18 repeating. That makes it a little bit more difficult when we have this 0.18 repeating. So the way we can set this up is we're looking for a fraction that is equal to this. So we're going to say there is a number that is equal to 2.181818, repeating on for eternity. When we have an equation with two things on each side, or one thing on each side that they're equal, we can do anything to one side as long as you do it to the other. In this case, we're going to multiply each side by 100. If we multiply this side by 100, we're going to end up with 100n. On the other side, if we multiply it by 100, we're going to have 218.1818. Again, this is going to keep going on forever. Here's where we're going to get rid of that. What we're going to do is subtract n from each side. So if we subtract n from here and subtract n from here, this one's really easy. If you have 100n and you take one away, you're only left with 99, right? Now this side, this n, it's a little bit complicated seeming, right? Here's how we're going to make it easier. Instead of just subtracting n, let's just say we're going to subtract 2.18 repeating. Essentially, that is what n is. These two things are equal. It's 2.18 repeating. Subtracting it from this, we're going to have that 0.18, as long as it goes on forever, we're essentially going to cancel this non-terminating repeating decimal. This 0.18, we're taking that off. That's going to cancel out. So we are left with 218 minus 2, which will be 216. Now if we want to find out that n, we need to get it by itself. We're going to have to divide by 99. So we divide each side by 99. What's going to happen here? 99 divided by 99 is 1. All we have left is n. Here we're going to have 216 over 99. Now we want to simplify this. We know that 216 is greater than 99, so we're going to find out how many times. Well, 99 is one less than 100. We're going to take out 2 of them to start out with. So if we take out 2, that's going to go in. That's 99 times 2 is 198. We're going to have 18 over 99 left. Now can this simplify? Well, I can see right off the bat 3 goes into each of those. Can you guys think of anything that would be higher than that would go into them? Anything higher than 3 that you could think of? How about 9? 9 goes into 18, 9 goes into 99. If we divide this, we want to simplify this. 18 divided by 9 is 2. We're going to keep the whole number of 2. We're not simplifying that. 18 divided by 9 is 2. So we simplify that. 99 divided by 9 is 11. Now these have no common anything, right? 2 and 11. So this is going to be our fraction equivalent to this non-terminating decimal.